Drinking water is one of the most unremarkable actions in our daily life. But when the water supply network is contaminated during a flooding, for example, there can be a lot of victims in an extremely short time. To guarantee the safety and quality of drinking water, the European project DINAMICS could offer a solution: an integrated, automated and highly sensitive measurement device based on a nanobiological sensor to simultaneously monitor the presence of several viruses or dangerous bacteria in water.
This machine produces the biosensors for our DINAMICS project. Each line printed here contains the DNA of a specific bacteria. The DNA is integrated onto the plastic surface, and then its parts are integrated into a microchip. With this biochip, we can prove the presence of bacteria in drinking water in order to ensure safety against bioterrorism attacks.
This microfluid chip is integrated in a mobile detection system of water, which is roughly the size of a suitcase.
The system must be set up in various locations after treatment by water purification stations in order to guarantee safety.
On location, this system will filter a sample of water to get rid of impurities and to strongly reduce the sample volume. Finally, it will contain only organisms. At the next step, the DNA of each pathogen found in the sample is isolated and copied to increase its concentration so it can be more easily identified.
This sample contains the DNA of all the bacteria found in the water we filtered. Each DNA was increased by a billionfold.
At the end of the process, this highly concentrated water sample will be put in contact with the microfluid biochip of the system to check for the presence of a pathogen's DNA.
Only in the spots where the bacteria DNA correspond to the DNA of the sensor will the two DNAs bind.
Once the two DNAs are bound, the detection system will add an enzyme to the water sample. Through a chemical reaction called chemiluminescence, the DNAs emit light and are identified. But at the University of Bologna in Italy, researchers with the DINAMICS project have also set up a way to identify and measure the concentration of bacteria and viruses in the water with a different kind of nanobiological sensor.
It's an electrochemical sensor that changes into electrical signals the bound DNA molecules of a pathogen on this surface. This system sends electrical signals to the sensor, which responds with signals that are read by the computer. That's the peaks you see here. The scale of the signal is proportional to the quantity of, for example, hepatitis E genome molecules contained in the sample.
If biological contamination were detected, an alert in the system and an evaluation of the danger would be communicated to the authorities by mobile phone or email.
The methods of molecular analysis currently used require a water sample to be taken and brought to a laboratory. Our goal is to bring our laboratory to the water, so the time it takes to analyze the sample is significantly reduced, down to an hour at best.
By ensuring the constant monitoring of our drinking water, public safety will be increased. The know-how developed within the project can also be easily transferred to different sensing applications and allows the supervision of sanitary conditions in other sectors, such as hospitals or pharmaceutical manufacturing.